Okay, so 3D scanning and printing explained, and I'm going to use Ocean's 8 to do it. So as I mentioned before, if you haven't seen the movie, spoiler alert, it won't matter if you haven't seen it because I'm going to walk you through the entire thing, which hence the spoiler alert. Okay, so here we go. Should be with this. All right, so I skipped a slide there. All right, so Ocean's 8 is, if you're familiar with Ocean's 11 and so forth, Ocean's 12, all that with George Clooney, Brad Pitt, and by the way, as I'm talking, feel free to stop me and ask for clarification. So Ocean's 8 came out in 2018. It was the woman-led movie with Sandra Bullock being George Clooney's character's sister. Anyway, so she comes up with this heist and gathers all these women to help her. And basically, it's a jewelry heist movie. The idea is that they're going to steal this necklace. It's worth $150 million from Anne Hathaway's character during the Met Gala. And they do this by 3D scanning the necklace and then 3D printing it, and then just swapping it out with the actual necklace. So we're going to talk about 3D scanning and 3D printing, and I'm really not necessarily going to focus so much on the movie, but I'm using it as a guide because there's really so much to the technology that I could probably just sit around and talk about it forever. So I'm really just going to rein it in by using the technology in the movie. Okay, so traditional scanning, obviously it's a 2D, scanner. You're probably used to this. That is the scanner that we have downstairs in the Creative Studio. We have this one, and we have another one where you can actually scan slides or other transparencies. But traditionally, you would scan a flat object, a piece of paper, a photo, and then you create a digital file from that scan. So 3D scanning, as it implies, is you're actually creating a 3D model from the scan. This scanner, the Einscan SP, as you can see, is $2,600. This is the scanner that I believe they have in our UMIT Academic Technologies that they've loaned out to faculty who want to do 3D scanning. As you can see, there's like a little device that's propped up on this area. The controller is spun around on this turntable thing, and this scans all aspects, all sides of it. So pretty neat. But with this scanner, you can see there might be some limitations in size. All right, so here is another scanner from the same company. It's slightly cheaper. Let's see. Oh yeah. Okay, so here you can see on the scanner, the little Pokemon is turning around, and you can see how the little lights are lighting up. And as it moves around, it's creating the 3D model that you can see on the monitor. This type of scanner wouldn't work with Ocean's 8 because it's too small for the necklace, and plus, they'd be putting the necklace on a 3D scanner, so it's not very inconspicuous, if you will. And then here's an example of 3D model and what it ends up kind of looking like when you've already created one. You can move around the model and really see all the aspects of it. And depending on the 3D model you make, you might actually even include all the colors. You may have seen some museum websites will have 3D models of certain objects, and all the color is retained. But I'll mention it later, I'll mention it now. It's not currently feasible for a 3D printer to print that many colors that might appear on certain 3D models, but maybe in the future. But this way you get to experience the object from all sides with the actual color. So it looks like a 3D photograph, I think is the easiest way to say it. And that is the scanner from this particular viewing. It's a Kickstarter, so it's not really out yet. All right, so a 3D model is made up of a series of polygons. That's really what you get. You don't notice it too much in some of the 3D models that you might see online. The polygons really come in when you get the mesh view. That's what we call it. And then it looks something like the images on the right. The more polygons that you have, the better the resolution, the more aspects you can actually see of it. When I mentioned viewing software is not common yet, I mean this is a slideshow. I can't embed the software to show you a 3D model and spin it around into a PowerPoint, at least not yet. I can do it into a website, and YouTube can also do it with 360 video. You kind of just hold the picture and then drag the mouse, and then it'll kind of flip so you can see the 3D model. You can't do that here yet. It's not a JPEG, it's not a PNG, you know, it's not an animated GIF. So I can't really show you on the slideshow, hence the video in the previous slide. But yeah, I do want to mention the more polygons, the higher the resolution, because this is really important when you're scanning objects that are smaller and when you want to make sure that the 3D model is true to the original. Okay, so let's talk about 3D scanning in Ocean's 8. The way that they do it here, that's Helena Bonham Carter, and she's using these glasses that are 3D scanning the object. So let's, and then this is what it looks like as she's scanning. So it's interesting because like, so the blue area is the area that's already been scanned, and it's scanning the diamonds and the metal, you know, at the same time. The diamonds, they refract light, so that's going to be very difficult to scan. Keep that in mind, because I'm going to be mentioning the fact that diamonds refract light constantly as an issue with 3D scanning and with 3D printing. But this is basically what it looks like as she's scanning. And I do have a video of that. On the left-hand side, you see the 3D scan coming in to the other people in the gang as Helena Bonham Carter tries to very conspicuously zoom in and move around this necklace as she's 3D scanning it. And you can see the guy from Cartier in the background. It's like, what is this lady doing? And like, why is she moving around so much? And you can see the percentage of the scan coming in until it's all blue. It's all good. She's got the scan. So let's talk about, you know, is that possible? You can 3D scan with a camera. This is actually Ray-Ban smart glasses, which has a camera built into the glasses. So theoretically, if you had the right software, you could do a 3D scan with glasses that had cameras in them. You can 3D scan from a phone, and I'll get into that. It really just depends on the software connecting to the camera. You can also do photographs at multiple angles, which is a different type of 3D scanning that I'll also mention. But I do want to say that it is not completely impossible that you would be able to create a 3D scan by having some kind of spy glasses on. Currently, a good resolution on spy glasses is 5 megapixels as opposed to an iPhone 13, which is 12. So you're better off probably scanning from your phone, even though I don't think they could have done that in the movie. That would have looked a little bit weird. So let's talk about 3D scanning with your camera. Because if you have a good enough phone, I don't, I have an iPhone 6, but if you have a higher end phone, you could already do this today. So let me show you this video of this person scanning another person as he moves the phone around. And that's reminiscent of Helena Bonham Carter's character, as you saw her moving around the necklace as the glasses went ahead and did the 3D scan. The 2 images there is just because he scanned her with 2 different methods. The one on the right being the one he did on the phone. Let's move on. So 3D scanning with a camera. I have a few softwares that you can download, a few apps you can download to your phone. Some of these are iOS and some of them are Android, and some of them are both. Some are free, some are not. But you can like go ahead and you can see some YouTube videos of pretty much every single one of these. So if you wanted to try it out, you can look it up and see how it goes. But yeah, you can 3D scan with your camera. So pretty simple. You might have seen in the video on the right, some of the angles don't look like they've really scanned very well. But that's because, you know, it's the scanning is really not one of the main features of your phone. So it's just a bonus. It's not a scanner that was dedicated for that and therefore would be able to do better scans. So, all right. So let's talk about 3D scanning technology, because not all 3D scanners use the same method to create a 3D model. We'll start with photogrammetry, which I mentioned briefly, and that is doing a 3D model with a series of photographs. Now, this video here is one of ours. You can see our former staff person, Morgan. She's taking a bunch of pictures of this coral as it's spun on a turntable. And then Autodesk Remake is now called Autodesk Recap. But it built a 3D model with, I think it was like 200 photographs that we took. It was a pretty good model. Unfortunately, it didn't have the depth, like the coral has all these holes in it and it didn't really capture that. But it's one method of doing it, and maybe they've progressed. This is a pretty old video. So yeah, so 3D scanning and reflective surfaces, which I mentioned before. It would be very difficult to do with photogrammetry, but basically all 3D scanning would have this problem, scanning reflective surfaces. There's a forum there on Reddit, and I will have all this as a PDF that will be linked from the YouTube video that we're recording for this. So there's a Reddit forum that discusses what you might want to do if it's a reflective surface. So, not just diamonds, but glass, anything that has a mirror. Yeah, like if you were doing a 3D scan of a motorcycle helmet, it would be very difficult. Even some areas that are too dark will be then reflective. Usually the advice is to put some like powder over it that will, stop the reflection, and there's a special spray specifically for that as well. Yeah. So let's talk about 3D scanning with lasers. That was photogrammetry. Now we're moving on to lasers. You'll recognize the Einscan down there again, and that is a laser method of 3D scanning. And basically, as it says, they project a laser line or multiple lines onto an object, and then they capture the reflection with a single sensor or multiple sensors. The Einscan was 2,600, but these vary in price range from like $400 to $40,000. Of course, the more expensive ones are capturing higher resolution, so more of those polygons to get a better model, and then later a better 3D print. This is the matter and form, which is like 749, nice slow end. There's the Faro Freestyle, 12,000, and then the Zeiss is 40,000. I wasn't kidding, but it's a good 3D scanner. I've never used it, and I might never. It's $40,000. So yeah, 3D scanning with lasers. You can scan tougher surfaces. So more shiny stuff than you would with photogrammetry. This would probably be easier if you had a laser 3D scanner than if it was photogrammetry. It is less sensitive to changing light conditions, so you're more likely to be able to scan something that's outdoors or some other place. And it's portable, so I'll show you the video. Oh, there's some more 3D scanner buyers. Yeah, you can see this video where the guy is just scanning something outdoors, and then if you look really closely, you can see the red lasers, and here you can see the blue ones. So back to Ocean's 8, now something that she could have been doing there, because the guy would have been like, what are you doing? You're obviously, 3D scanning this or something. Something's going on. But it's a good 3D scanner. Okay, so the LiDAR scanner, I'm not sure if I'm pronouncing that correctly. LiDAR, laser scanning. It's very similar, honestly, to the laser one. But LiDAR determines ranges by targeting an object with a laser and measuring the time for the reflected light to return to the receiver. And as you can see here from iPhone 12, you have an iPhone 12 and up, you already have a LiDAR scanner built into your phone for some reason. It's there. I haven't tried it yet, but I am curious. But yeah, so like I mentioned, it's totally doable. And if you have the LiDAR scanner here on this phone, I see no reason why, if you actually wanted to, you could like put that into your spy glasses and, do some 3D scanning that way. All right, so 3D scanning with light, I'm sorry, yeah, laser. Similar to scanning with lasers, except that it uses LEDs. The Structure Sensor Pro that you can mount on an iPad has been around for a few years, actually. I believe they also did have one of those in Academic Technologies. And the Creaform Go Scan Spark, $3,700, but you know, it's also a very good scanner. So depends on what you're doing with it. So here's an example of the scanner, and you can see it's got these bursts of light that are creating the 3D model there on the screen. So pretty neat. Okay. All right. Can you 3D scan a diamond, right? I mean, that's why I'm talking about Ocean's 8. And the truth is you can. It's not easy, but it is possible. Not like in the movie, but there's actually, besides other scanners that you could use, there is a 3D scanner that is specifically made for scanning gemstones. It's been around for a few years by this company, and they advertise it for gemstone appraisers. So they can, you know, 3D scan it and with the model see if there's any issues with the gem, or, you know, see the cut of it and really get whatever information gemstone appraisers need. But yes, you can. It's like this little device here, and you put the gemstone in it. So it wouldn't work with you know, the entire necklace, but you can. So final notes on 3D scanning. And some of this information came from a very specific article where this image is from. So there are other types of 3D scanners. For example, contact scanning, where the scanner like physically touches the item and creates a scan that way. And a CAT scan or a CT scan that you've probably heard of in medical uses, you can actually create a 3D model from that. And we've gotten those from, excuse me, usually archaeology that's done some kind of CAT scan and has a 3D model that, you know, they want printed out. Some 3D scanners combine technologies. So I did mention a few separate ones, but some of them are combined. That $40,000 scanner that I mentioned before, which I think was a laser scanner, they have photogrammetry technology built into it. I'll mention, yes, the shiny objects, the highest the most thing that was recommended for that is like, you know, like diamonds and so forth, is to actually coat the object in powder or paint. Or the specific spray, basically to reduce the light refraction and make it easier to scan. Yeah, dark surfaces might also be reflective. 3D models can actually be made from 2D photographs. So that might have been something else they could do. They already had a photo of the necklace, so they might have just skipped the entire 3D scanning process and use the software that is able to create 3D models from a 2D photograph. There's an example there if you're really interested. But it would probably have been easier with the necklace, since the necklace is kind of flat, you know, not completely flat, but kind of flat. And then, yeah, I mentioned this photo. This is the Artec Leo 3D scanner. It's better at scanning reflective surfaces as some of your run-of-the-mill scanners. And you'll notice I have two kind of little input devices here. So I think if you had, you know, some really high-end spy glasses, this could be on one side and this could be in the other. And then maybe, yes, you could visually 3D scan some diamonds with whatever glasses you're wearing on your head. All right, so let's talk about 3D printing. This photo is from Ocean's 8. They printed a practice statue there using what the person called zirconium. And I'll get into that because I had to learn a whole bunch of other stuff that I didn't really realize as I was making this presentation. So what is 3D printing? Oh, you know, it's pretty straightforward. It's sometimes called additive manufacturing. That might have been what it was called mostly before, because 3D printing has actually been around for a long time. It just hasn't been available to as many people as it is now. But additive manufacturing is the construction of a three-dimensional object. Material is deposited, joined, or solidified under computer control. That's from Wikipedia. And I always just say it's making a it's a three-dimensional object being made using a printer. So this is the Form 1. This is the first 3D printer we had in the library. its stereolithography, which I'll get into, was a little bit more firepower than we needed to start off with in our 3D printing services, but it went on to bigger and better things for a while in architecture and engineering. Then we had the M3Ds, which are, as you can see, are relatively, it's a lot cheaper. They were smaller, the resolution wasn't as high, it's a cheaper printer, but they used to have really great customer service at that company. And it's usually the printer that I used to recommend when people ask me, what 3D printer could they get, their son who was interested in 3D printing. It was always son, it was never daughter. I'm very sorry, but that's, I was waiting for, like, my daughter's interested in 3D printing, alas. And then currently we have the Ultimaker 3s. They're pretty good, honestly. We have 3 of them, 4 if you count the broken one. They were all donated to us by the Academic Technologies department, and we're still using them, and pretty sure we're printing right now as I speak. All right, so let's talk about the resolution, which I talked about in scanning, and then it's very relevant when you want to print. The better the scan, the more detail it will have, and then you can, print it fairly well. But then you also need the 3D printer that can print a good resolution. And I think it's very apparent in this photograph. You have these 2 images. The one on the left, obviously the printer either doesn't have a higher resolution or it was set as a low resolution, because higher resolution also means that the print is going to take a lot longer. I can squeeze a 3-hour print down into about 45 minutes, but that print is not going to look great. So you probably want that extra time. I also want you to note here the layers, because this is an example of what we call FDM printing, which I'll mention more about later. It's very, the lines will be visible on a lower resolution print because there are just less of them. Oh, that's poor guy there. All right, so types of 3D printers. There's more than 3. I'm just not going to be talking about all of them because, again, that's just going to take forever. But yeah, so like 3D scanners, there are different types of 3D printers, some more well-known than others. And we're going to start with FDM because not only is it the most popular, but it's the one that we see in the movie. Specifically, Ocean's 8 is showing a MakerBot replicator Z18, which is currently not being made anymore, but that's what they were using. All right, so yeah, the FDM, which is fused deposition modeling, is a 3D printing process that uses continuous filament of thermoplastic material. And most 3D printing is made with some type of plastic polymer material. Yeah, I'm not gonna read all that. So our Ultimaker is also an FDM printer. Basically, the filament, which is like a nice, thin sheet of plastic, not really a sheet, it's like a thin tool. It's like a spaghetti of plastic all rolled into this thing. And it gets fed into this nozzle where it is heated up, and then line by line, it creates this 3D model. And the nozzle for the Ultimaker is right out here. Ultimaker actually has a dual extruder, which I'll talk about also in a second. But that's the FDM. So here's, there's a video of our FDM. It is the most common type of 3D printer that for personal use, because it's the most affordable. So if somebody has a 3D printer at home, it's more than likely an FDM. You can get one at Best Buy for $229. I know ours was $3,500, but you can, get one relatively cheap. That's a good way to start out, and that's what I recommend to, again, the parents who want their kids are interested in 3D printing. But the layers are visible. Like I mentioned, the plastic is just building one top of the other. And, our Ultimaker is even at the highest resolution. If you like hold it up to your eye, you can see the lines. And the reason that's important is that would never work for trying to recreate any kind of diamond or gemstone that's going to refract light. You would see the layers, it just wouldn't work. But anyway, so there's the Ultimaker. Let me pause there for a second. Go back. This white material was supposed to be the supports. It failed, as you can read here, and it wasn't able to support the rest of the print. Basically, as you're building layers, if some part of your print would be hanging in the air, more plastic needs to be printed to be able to support it. So it failed, and then yeah, that's what it ended up looking like. Dual extruders on the FDM. I mentioned before, the Ultimaker does have a dual extruder. We just don't tend to necessarily use it. But that means that if it's in the model, if it's in the 3D model information, you can go ahead and build different areas in different colors as the machine is going. You know, the red would stop when the yellow needs to come in, and so forth. And you could create something like that. Most FDMs just have the one extruder. You build the model, and if you want color on it, then you paint it. I did see one FDM that was doing 4 extruders, but I never saw it in person. It was still in the development mode. I actually don't even know if they were if they ended up being for sale. Okay, so stereolithography I mentioned is the first one we had here at the library. This is from Formlabs. To my knowledge, they're the only company that makes a stereolithography printer that can be afforded by more people. The company that originally made the stereolithography printer, which I think is 3D Systems, is the name of the company. It's more expensive. So the difference here is that they're using a polymer resin, what I basically describe as kind of a liquid plastic, and it's hardened by lasers. You see coming up on the ground there. The resolution on these is amazing. Yeah, you don't really see any lines. It's pretty gorgeous, and you can make really small items that have very, very good details on them. They are kind of a huge mess because of the liquid plastic. I have a bunch of like plastic left over on top of my table that I can't get out. My coworker ruined like 3 pairs of pants because the plastic fell on her. But you can see, look at that level of detail. Like it's amazing. And they have different types of plastics as far as how hard it is or how soft and flexible it is. They're by Form 3, the Form 3, they're by the Form 3. But you can see here at this clear resin plastic, and even in the beginning, you're not going to be able to make a diamond kind of thing that reflects the light, but it is very, very nice 3D printer. So here's a close-up of the FDM and the SLA, so you can really take home like those lines and what the difference is. Yeah, so that's where we are. But again, the SLA a little bit more expensive. You can't find a $200 SLA at this point, but it's beautiful. We have some examples downstairs. All right, so selective laser sintering, SLS, and or direct metal laser sintering, DMLS, is a metal 3D printer, or I should say printers. The EOS is, I believe, what the Engineering Johnson & Johnson lab has. I'm not sure if it's this specific model, but it is I'm pretty sure it is the brand. These printers are minimum about $1 million. So at least, yeah, minimum. I think they go up to about 3. But they're pretty similar, except as you can see in the second bullet point, the SLM heats the metal powder until it fully melts into a liquid, but the DMLS does not melt the metal powder. And I believe the DMLS is what we have on campus. But again, don't quote me on that. I believe it is. It's actually pretty beautiful to watch. So let me start there. You can see the little lasers are starting off on the print. Let me skip ahead to, and then here you can see the metal powder coming up off. This is kind of after the print fact, like I mentioned, it's metal powder that kind of gets molded together by these lasers. And then, I mean, I find this part so satisfying, which is why I'm playing the video. You kind of just brush off that powder, and what you're left with is the object that you 3D printed. Let me skip ahead so you can kind of. Yeah, I mean, look at that. And that's just powder that gets brushed away. I don't know why, I just find it so satisfying to look at. Okay. All right, so unconventional 3D printing. This is a chocolate 3D printer. I'm sure you might have heard of those. I'm like, wait, I think I heard that. Yes, you can. There are specifically 3D printers that are made for foods. You can 3D print a house. Sometimes people ask me about that. This is, yeah, just you can see layer by layer putting in cement, and it's kind of like this independent system. You see how it was rigged up here, and then yes, you can just go ahead and make a 3D printed house. Not sure how that would do in Florida with the hurricanes, but um, it is a possible thing that exists. So 3D printing jewelry, going back to Ocean's 8, you can 3D print jewelry. This top image there with the gold bracelet, it's metal. You can 3D print in different types of metal, including gold. There's Anne Hathaway wearing the necklace. And then I included this picture on the right of Katie Holmes, because that's Katie Holmes at the actual Met Gala, not in the movie, although she does appear in the movie. But it's a 3D print here that's attached to her dress. So we've seen 3D printing at the Met Gala. What was I gonna say? Oh yeah, so the 3D printing jewelry, I did read up a little bit about it, and most people recommended to use 3D printing as a way to cast a model that then you would use for the metal, some kind of liquid metal to form later on, but not necessarily to print in metal, because as I mentioned, that 3D printer that does metal is about $1 million. But yeah, so making a cast that will later be used is usually what I see. And I mean, we've done that in the library as well for people who are just 3D printing molds for something else. Yeah, so let me get into zirconium, because in the movie they said that little statue that they built of the clear statue David, I'm guessing it's like, oh, this is zirconium. So here is zirconium. And I found out that zirconium is used a lot in 3D printing for teeth and yeah, the what do you call that? I hope you know what I'm talking about. But yeah, fake teeth is normally what it's used for, not necessarily for anything clear, because it turns out that zirconium and cubic zirconia are actually two different things. Cubic zirconia is a combination of zirconium with oxygen, so it's not just zirconium. You know, the things you learn. But you can see here different printing methods, and you know, they're trying to get to clear, and that's pretty much as close as you get. But again, nothing really that would be confused for a diamond, because at least currently no 3D printed stones would reflect or refract the light correctly, not like a diamond and not like a cubic zirconium if you were going to use that, you know, to swap out your $150 million necklace. All right, so final thoughts on Ocean's 8. Can it be done? Just to go through it, this was their plan. They 3D scanned the necklace. They printed some gemstones in the zirconium. They set the gemstones in metal. I bring that up because the maker bot that they use in the movie is not a dual extruder. It's a single extruder, and which means they would have only been able to print one at a time, the diamond or the metal casting. Like, you know, if this was some future technology that you could do that for less than $5,000. And later on in the movie, you see they're printing the gemstones separately. So yeah, so they printed the gemstones and then they set it into the metal. They created their necklace and they swapped it out. You know, everything's great. But, ultimately that really wouldn't have worked. You have the spy glasses, which currently can't do what they do in the movie. It would have been easier to either just, use an iPhone or create a 3D model from the photograph. The 3D printing would never have been possible on that machine because it's an FDM. FDM, you can see the little lines. But currently, there is no 3D printer that can print a gemstone that will refract light or will sparkle, basically, the way a diamond does. So no, you really couldn't have done it that way. Sorry, guys. So I have a new plan. Just stick to Ocean's 8 theme, and that is Amita, because Mindy Kaling plays Amita, a jewelry worker, a jeweler that makes jewelry in the store. So let's say here's an article from All3DP. It was a person who 3D printed a ring. They 3D printed the metal. It was all nice, fancy design. And once they 3D printed the metal, they got some cheap cubic zirconias online, and they made this engagement ring. So, Mindy's character works in a jewelry store. It shouldn't have been very difficult for her to get her hands on some cubic zirconias, which would have been way cheaper than a 3D printer, and, had made a necklace this way, since we can't 3D print gemstones for real. So yeah, that is my grand plan. I have solved the problem. There I am. We can now call this movie Ocean's 9. Thank you. And I do have some further reading links that, again, this PDF will be linked to the YouTube video once it goes up online. So any questions? No? Okay. Well, if there's any questions, you know how to find me, and this video will probably be online next week on YouTube. So thank you very much. Bye.